Alright, today's lesson is 2.1.1 in the Course 2 book, and the question is about working with fractions, describing portions in different ways. So we're going to start with the first question on this slide is complete the representations of the portions web for each number below. So if you remember, portion web has a fraction on the top, decimal on the left, percent on the right, and then either words or symbols in the middle, and all of these are all interrelated. Okay, so we're going to do these four, and just to remind us how to do those portions web. So let's set this up. First, this is lesson 2.1.2, and this is problem from the book. This is problem number 18. Alright, so our first portions web we did was this fraction. The second one will be this decimal. That's a 5. And the next one will be 3/5, and this other one will be that fraction. Okay, so we're going to start with the first one. If you have paused this and you already started filling them out, let's check our answers. So the first one, we have 7/10, and that would just be 7 divided by 10, or using the place value, we can just write it like this as a decimal, and then move it twice to the right to get the percent. Alright, and then this one is 0.75, so the easiest one to get would be the percent. And then what would that be as a decimal? Well, we can put 75 over 100 and just keep reducing it, and we should get 3/4. Alright, then we have 3/5. This is what it looks like as a fraction. As a decimal, we have this, and as a percent is 60%. Alright, now 5/8. Not sure as a percent, but as a decimal, we can do 5 divided by 8, which is 0.625. And then 62.5%. Alright, and we can say 5/8. Okay, and we didn't do this one. This is 3/4, and I'm going to do a drawing for that one. Here's 1, 2, 3, showing 3/4. Okay, and oh, we didn't do this one either. 7/10. Alright, so that's our practice with the portions web. Now let's move to the next problem. Since 0.7 is described in words as 7/10, it's not a surprise that the equivalent fraction is 7 over 10. So use the names of the fractions like 23/100ths to rewrite each terminating decimal as a fraction using what we know about place value. Okay, so look at these. You should have a good idea kind of what they might look like. So we'll start with the first one. This is number 19 in our book. The first one we'll call A is 0.19. So what would that be as a fraction? Okay, if you know place values, you know that this is equal to 19/100ths. Okay, for question B, it's 0.391, and what would that be as a decimal? Well, we know that 3 of those place values is thousandths, so 391 over 1,000. And then for C, 0.001, what is that equal to? And again, these are thousandths, but we have only one of those thousandths. Okay, 001 means we only have one of those. Okay, and so the next one is A, B, C, D. We have 0.019. What would that be equal to? And you should have 19 thousandths. Okay, because that 0 is kind of like a placeholder. You have 3 decimal places, but only 2 numbers in the numerator of the fraction. And E, we have 0.3, which is equal to 3/10. And lastly, we have F, which is 0.524, which is equal to 524 thousandths. Okay, so you see place value and denominator are all related. We have 3 numbers in the decimal places and thousands. 2 numbers, hundreds. 1 number, we have tenths. Okay, now the next question would be, how do I write 0.73 with the 7 and the 3 repeating? Because that bar means that's a repeating decimal. And can we write it as 73 hundredths? Okay, so let's think about that. So question 20, how do I write 0.73 with a bar over it as a fraction? Okay, so we want to know, well, since it's only 2 decimal places, is it 73 over 100? Okay, now some of you may be thinking, oh yeah, I think it is because we have 2 numbers there, and someone might be thinking no. So we'll come back to this question. And let's move on to the next. So Katrina is now responsible for finding the decimal equivalent for each of the numbers below. She thinks these fractions might have something to do with the decimals and fractions in the previous problem, but she's not sure. So we're going to use our calculator and find these different values. Okay, so our first one, and have your calculators out. You can pause this for everyone to get their calculators out. And problems number 21A. Our first problem is, our first expression is 19/99ths. Okay, and when we take out the calculator, 19/99ths means 19 divided by 99. We get 0.191919, and then that 2 is there only because there's a 1 followed by a 9. So it rounds off because it doesn't have that many spaces to put all those digits. So this is 0.19 repeating. Okay. So question B, we have 391 over 999. And what is that equal to? So we're looking at a calculator. We have 391 divided by 999, and we get 0.3913913913991. So the 391 repeats. 0.391. So let's pause it and see if anybody notices a pattern here, if you wish. All right, and then the third one, we have problem C. This is 3/9. What do you think it would be? So if you notice a pattern at this point, you might have said 0.3 repeating. Okay, now if we notice a pattern, this could be something that we can talk about, but let's move on to D and tell me if you can predict what would this be without looking at the calculator, without looking at any calculations. So put your calculators away, and this one is going to be 1/999th. All right, so first of all, don't look at your calculator. What do you think that would be? All right, go ahead and take out your calculator, and you'll see that it is 1 divided by 999, 0.001001, Okay, so we have a repeating pattern, 0.001. Was that what you predicted? Okay, now if it was, let's make sure that you really know what you're talking about here. And let's go to number E. We have 542 999ths. And take a guess. All right, so you should have guessed 0.542, 542, 542, 542, 542. And if so, I think you know what you're doing. But just to settle this, let's see question F. We have 19 999ths. All right, so if you got this, then you completely understand how to get these numbers. You should have 0.019019, 019. Okay, what's going on here? So what kind of patterns do we see? What do we see happening over and over and over again as we look at all these answers? Okay, so the first thing we see there are a bunch of denominators of 9s, right? So there are 9s in the denominator. Okay, anything else we see? We see the repeating digits that are in the decimal are the numerators of these numbers. We have a 3, we have a 19, we have a 1, and we have a 19. Okay, so the repeating digits are the numerators. The repeating digits are the numerators. Okay, now getting these two observations together and kind of noticing, well, that's a 19, but this isn't, and this is 19. That's a 1, but this isn't just a 1. That's a 19, but that's not just a 19. So what's going on here? So let's, before we state an actual rule, let's get together and solve these. So without a calculator, let's do number, well, this was G, saying what do they have in common. Number H, we have 0.24 repeating. And if I were to ask you to take that decimal and write it as a repeating fraction, what would that repeating fraction be? All right, so if you put 24 over 99, you are correct. That is the repeating decimal. Our next one is problem I. Okay, this one's not as easy. Let's see if you can get this one. What is 65 over 999? All right, and the answer that you should have gotten is 0.065, repeating. Okay, now, if you said 0.65, there's one thing that you might be overlooking And here is the rule. The rule says, first of all, why do all of these repeat? What do they all have in common that's not changing is they all have 9s in the denominator. So fractions with 9s in the denominator will repeat. Fractions with only 9s in the denominator will repeat. Okay, and so that's one thing that they all have in common. But there's a couple of things that we needed to pay attention to. And first is one of those guidelines. Okay, so these 9s, these repeat, but what are the things that we had to remember in order to get that decimal from that fraction? And it has to do something with the number of the 9s. What does the number of 9s tell us in the denominator? And you should have thought or said the number of 9s tells us how many digits repeat. 3 9s, 3 repeating digits. 1 9, 1 repeating digit. 2 9s, 2 repeating digits. All right, so that's the first thing. The amount of 9s tells us the number of repeating digits. The amount of 9s tells us the number of repeating digits. Okay, and one more thing that we need to remember is the numerator. The numerator indicates the numbers that repeat. So this numerator is a 1. There's a 1 that repeats, but it's in the thousands place. 19 is in the numerator, 19 repeats. 391 is in the numerator, 391 repeats. And 542, 19, and so on. Okay, so the numerator indicates the digits that repeat. Okay, but how can we say, because this is a 19, but not only the 19 repeats. This tells us how many digits repeat, but I only have 2 digits in my numerator. So that's what we need to do is we need to add zeros in front of the repeating digits. And we didn't do it every single time. We didn't do it here, we didn't do it here, because the number of 9s coincides with the number of digits in our numerator. So only when it's needed. 3 9s, we need 3 repeating digits. So throw that 0 before in the front of that repeating decimal. All right, so we'll just say when needed. Okay, and this is a very important point.